Hello and welcome to our second Algebra 2 video. In this video we're going to differentiate between three different forms that lines can be in and some of the useful things that these forms can do for us. So as you can see, we've got these three forms up here: slope-intercept form, standard form, and point-slope form. We're going to start with slope-intercept form, and we're going to talk about some of the advantages of having a line, having an equation in this form. And remember, we're talking only about lines with these three forms. So one of the advantages of having an equational line in this particular form is that the m value and the b value tell you something about the line. The m value is the slope of the line, and the b value is what's called the y-intercept of the line. Okay, and I think this is easy to remember because slope-intercept form tells you the slope and the y-intercept, which sort of kind of goes along nicely, slope and intercept. So when we have a line that's in this particular form, it's quite easy to graph. For instance, let's say we take the line y equals negative 2/3 x plus, we'll say plus 2. Alright, now I've got my pre-drawn axes here. Notice on my axes I labeled both my x and my y axis, and I also labeled the scale. That's going to be important for you this year. So the first thing I'm going to look at is, what is the y-intercept of this particular equation? Positive 2. So what I'm going to do is I'm going to go up 2, and that's going to be my first point, and I'm going to draw that point in right there. Now what I can look at to find another point is the slope of this function, negative 2/3. This is going to be the rise, this is going to be the run. The negative applies to one or the other, but not both. So we'll just say for now it applies to the top. So negative 2 for the rise would be down 2, and positive 3 for the run would be to the right 3. So going down 2 and to the right 3, I have a point, and that would be the second point on my line. Now let's say that the negative would apply to the 3 instead of the 2. So what that means is we would have a positive 2, which would be up 2, and then a negative 3, which would be to the left 3. And what you can see from that is that the pattern continues. We're still in that straight line, and the slope, whether we choose the 2 or the 3 to the negative, would be the same. Connecting those 3 points gives us our collection of points and our solutions for that particular equation. Because remember, what a line is, it's a collection of points that give you the solutions to this particular equation. So any point that lies on this particular line satisfies these conditions. Alright, very good. So that is slope-intercept form. It is very useful. Not all lines come in that form, but if we want, we could actually move around the equation so that it is into that form, if you really like that form. Secondly, we're going to look at standard form. Standard form I don't find is nice because A, B, and C don't really tell you a whole lot about the graph. Alright, and so we've got to do some manipulation and some work to figure out what are some important properties of this line. So let's start with an equation. Let's start with negative 2x plus 3y equals, let's go with 6. Okay, so this equation is in standard form, and the easiest way to graph something in standard form is to find x and y intercepts. Alright, finding the x and y intercepts is very easy when the equation of the line is in this particular form. So for example, what we're going to do is, let's first find the x-intercept. To find the x-intercept, that's the point that lies anywhere along the x-axis. And if any point is lying on the x-axis, that means it has a y value of 0. So to figure out where the x-intercept is, what I'm going to do is I'm going to plug in 0 for my y value. And solving for x by dividing by -2, I get -3 for an x-intercept. And then I can plug that value in right there. Finding the y-intercept is very similar. But with the y-intercept, any point that lies along the y-axis has a x value of 0. So I'm going to put 0 in for my x value. Dividing by 3, I get a y-intercept of 2. Now that I have both an x and a y-intercept, I can take those 2 points, connect them, and I have my collection of points that satisfies this particular linear equation. All right, wonderful. Finally, we have point-slope form. Point-slope form, you're not going to see a whole lot just given to you, but it's going to be very useful for you when you're trying to write equations of lines. With point-slope form, we have an m value, which again is our slope. So that's nice that the m continues to be our slope. But we also have an x1 and a y1 scattered into this equation, x1 being here, y1 being here. All that is, it's any point on the line. Any point in the world that lies on that line, okay? So for example, let's say we're trying to graph this, this particular equation. Y plus 3 equals 1/3 times the quantity x minus 1. All right. So we know a couple things from this graph, or from this equation. We know the slope is 1/3. So our rise is 1 and our run is 3. We also know one other point on this graph comes from this particular x value and this particular y value. Notice in our equation it's x minus x1. So our x1 is 1. And it's y minus y1. What do we have to minus to get plus 3? Well, we have to minus a -3 to get positive 3 by our y there. So what this tells us is that we have a point at 1 comma -3. 1, -3. And we have a slope of 1/3. Up 1 over 3. Or you could go down 1 left 3. And we have a beautiful line. And there you have it. The 3 different forms of lines and what they're useful for and what they stand for in terms of the graph. Finally, one last note on this video that I wanted to talk to you about is sometimes lines aren't always in this particular form. Okay, this is not in slope-intercept, standard, or point-slope form. That's okay. All right, we can manipulate it to make it in that particular form. There's lots of different ways that we can deal with this. I'm going to subtract 6 from both sides. Still not in either form, any of the forms. But then I'm going to divide by 3 to everything. And what you'll notice now is this equation is now in slope-intercept form. Slope and intercept. Alright, so don't just right away look at this and say, I don't know how to do this because it's not in any 3 of my forms. All these equations can be manipulated. So manipulate it until you are in a form that you're comfortable with. Once you're in a form that you're comfortable with, then you can go ahead and graph it. Alright, hopefully this video helps you understand the 3 different forms of linear equations and how we use them to graph. Enjoy your night.